So today we're going to be looking at the magneto key for our Cessna. We're going to actually be using an actual key combined with a switch, rotational switch with 9 positions. We're going to be using 5. We're going to be looking at how we can wire this up, how we can code this so it will send some commands to the game. For instance, set the magneto to both, set the magneto to start, and put it back into the previous position. All that will be covered. There's also new Arduino IDE 2.0 beta out that I will show you what differences are and what the downsides have been in my experience. So you guys can see if perhaps changing to the Arduino IDE 2.0 is something that's also a good fit for you. So let's just dive right in and see how we got this bad boy running. Okay, so the wiring diagram is actually pretty straightforward. Here we have our rotary switch, and there are 2 options. We could either connect every pin to a pin on our Arduino, but that would take up, it depends on how many you would like, but I would want to use 5 of the 9 positions. So that would take up 5 pins on our board, or we could also do with 1. Now, how do we achieve this? We'll add the 5 volts connection to our pole, and we'll add a 220R resistor, at each of the button pins. Let me show you on the device itself. Here we go. We're able to tell that each of these is connected to each other with a 220R resistor, and then there is a wire going to our A0 analog port. Now, what do these resistors do? The moment the switch is at position 1, it will take a path from resistor 1, resistor 2, resistor 3 and resistor 4 to our Arduino board by this cable. Okay, so let's say this yellow wire is the power that runs through it. To simplify it, if we put a switch in this position, the power will run through, well, let's even do it like this. It will run through resistor 1, run through resistor 2, it will run through resistor 3, up until the last one, etc. That is gonna limit the current that reaches the A0, and that will lower our value. The moment we switch this one up, so let's say we're gonna put it all here we go, it only passes to 3 resistors, and the value that comes in here is going to be higher than it was before. And we can just apply the same logic to the next one and the next one and the next one. Up to as many as you'd like. Maybe you need a bit stronger resistor or a weaker resistor, depending on how many pins you're using. That's just something to, test it out, see what works for you. And here we go. This will be the next one. So this is how the logic works behind it. Now it depends on which position it is, but the more resistors, the lower the value that will come in at our analog port, because it gets lesser for the first resistor, get weakened by the second, the signal gets weakened by the third, signal gets weakened by the fourth, etc. So if we use this data to actually read out the values from the analog pin instead of a digital one, we're able to determine which position the switch is in by only using 1 pin on our board instead of 5. So that is something that we've already used before in the multiple buttons for 1 pin in the, what was it? I believe it was the radio stack, if I'm correct. In that video we did the same with normal push buttons, and the same concept is something that we're doing right now with the rotary switch. So it's important that if you have the signal that goes to our analog 0 port, like we see on the screen right now, that we add a little resistor from this point to our ground. You could also just directly wire it up from this side to ground, but as long as there is a resistor going to ground, we're good. It's going to be the same as these ones, 220R. So we go from our rotary switch to our board. There is 1 pin going to the ground with a 220R resistor, and the other one just goes to our A0 to get the reading. It's a pretty simple setup, and I think it will save us many pins if we wanted to add 2 of these. Let's say when you have 2 magnetos instead of 1, then having 5 wires running to our board would become 10. and it would become unmanageable, especially since I want to add the toggles for the light strobe beacons as well to the same device. I want to add the, how do you call it? The master battery, master avionics. So those are all things that need to go to the same board, and I don't want to multiplex when I don't have to or anything like that. So this is the most easy approach to do this. Okay, we just saw how we wired up this device, and we're going to be using it as a kind of a voltage divider, where we check what the value is depending on how many resistors the current has to pass. It's going to be either higher or a lower value. Well, how can we check the values? Well, going to be quite simple. I'm going to say const byte. I'm going to say switch pin. First located pin, and it's connected to A0 in my case. Now I'm using the new Arduino IDE 2.0 beta. It's great because I'm going to show you something that it's amazing. Let's do include bits and droids light connector .h. Oh, mouthful always. So now we can do bits and droids flight connector. It automatically fills in the gaps. I'm going to create a connector that is false. Here we go. Now what you could do in the loop block, for instance, what is kind of new is if I do connector, it will autofill it. If I do dots, say okay. So apparently you need to select the COM port for it to recognize what kind of functions it must suggest. So in my case, if I do connector dot, it will give me a list of all available options. Well, not all, but most available options, what he thinks is more appropriate for the context. So let's say if I want to do send, I get all the sends. In this case, I don't know, it's still more than there is in here. So we can do send magneto. It will show you everything that there's in there for send magneto. Pretty neat feature. The only downside is that if you try to upload this code to your board, I encountered sometimes that it will say that your port is busy while it isn't. So what I did, I typed it in this editor and then just copy pasted it into the old Arduino IDE and just upload it from there because that was working fine. So I wouldn't say I'll jump ship from the old IDE into the new one. I like the new one, especially for typing, but uploading has been quite troubling. So what I'm doing is I'm typing in here and paste it over in the old IDE to upload it. But that's up to you. I put the link down in the description as well, so you can look for yourself what is the best fit. So we got a library, we got a switch pin. We're going to be using our mode, which is going to tell us in which position we are and check against other positions if it's already in there, that we don't resend our command over and over again. And we need an int, which is going to be the switch value. This is going to be the value that we read from the analog port and the value that we're going to be checking against to see in which position the switch is in. So the first thing that we're going to do is do serial.println. And we're going to be printing the switch value. Now we haven't defined anything for the switch value yet. So we're going to do switch value is analog read. See, perfect, it will autofill it for you. Analog read. And what? We want to read the switch pin. Here we go. Add a little delay so we have some wiggle room to work with. Or else it will just keep spamming the thingy. Like I mentioned, this is a bit, here we go, new sketch. This is the big downside, upload. If you take a look at the serial monitor, where is it? Here it is. Oh. This one. We're able to spot some values coming in 594 or 549. So 1023.0 or 1023 is our max value. That means that it runs through no resistors at all. So in the sketch, we know that we're at this position. because it will go from here to here and run to our A0 without passing any resistors. Well, with that knowledge, we can check. Here we go, 1023. We have 548, 375, 284, and 228. Now let's write these down quickly. As a comment, 228, 284, 375, 549, and 1023. Now these can vary slightly, so we're going to create a range for it to check against to see if it works and at what position we're in at that moment. So what we're going to do, we don't need the serial print anymore. We don't need the delay. We do need to switch value. We're going to say if switch value. Now the first range is going to be smaller than 20. And why is that? Because we also have at 0. If it's at another position than one of the 5 defined, it's going to be at 0 because no connection is made. I don't have anything hooked up there, but we don't want it to execute any code. So if this is the case, we won't do anything. And now we're going to see why it's important to have it in there as anyway. Let's say else if. So only if this statement is false, we're going to execute this block. If it's true, we're going to skip this entire check going forward. So we know if it's smaller, if switch value is smaller than, let's say 228, so we're going to say 250. This will give us a bit of a range between this one and this one to check if any inconsistencies come up that this won't jump to either one of them or skip one of them. So we just copy paste this 1, 2, 3, 1, 2, 3, 4, 5. I replace these with values like 320. So somewhere in between here. Somewhere in between here is going to be, let's say 400. It doesn't have to be that precise. So there's going to be 500, why not? And 1100. Oh, 1100. Here we go. So only if this is false, we're going to check for if it's smaller than this. Only if this is false, we're going to check for this. Only if all before are false, etc. That is the else if statement. If we would create if statements, it would check if it's smaller than 20. If it's smaller than 20, the next if statement would also be true because it's going to be smaller than 250 as well. It's going to check again if it's smaller than 320. That is true as well. So we want to avoid this. In order to send a command with the connector, we just do serial.print line, print line connector dot send magneto. Let's see, magneto start. Go. Now I'm quickly going to cheat because I've already written this code once. See the order, start both left, right, and off. So I'm going to do this, copy paste, copy paste, copy paste, copy paste. Print line, am I missing something? Oh, this is fine, right? Connection sent me. Yeah, I think it's just bugging out. Send magneto both. Send magneto left. Send magneto right. And send magneto off. So this would already be sufficient to send our command to the connector. The only downside is that if we are in position 1, let's say 250, or that's position 5, either way, it will always be true, this statement, so it will keep executing the serial.print line, and it would just be prone to error and take a bandwidth that we don't want to use or don't need to use. So we're just going to work with some modes. If mode is not equal to 1, and I'll show you in a second. mode is 1. If we dump this down, we first check if the value is below 250. Let's say that is the case. It's going to be 230, 228. If the mode is then checked, so right now the mode is nothing, right? The moment it's not 1, so nothing is not 1, we print a line and we set the mode to 1. The next time this block gets looped through, it's going to check the switch value. This part will be true. So it will look at the code inside and it will see, oh, but right now the mode has been set to 1, so we don't execute this block. Now we can do the same at these other parts. Let's see, 1. So here we go, 2, 3, 4, 5. And we say mode 2, 3. Let's see that we don't mess this up. 2, 3, 4, 5. And we believe we forgot the brackets as well. There you go, mode 2, mode 1. Yeah. So because we made different modes, we can switch the key. It will go into the next bracket. The mode will be set to that bracket, and only if the mode changes back to this bracket, the code will be executed. This will just give us more stability and will make sure that we don't send 20 commands per second. So the only thing that's left to do is just like I already mentioned, I'm just going to copy it in here. Upload. Yeah. Right, left, both. Start. And we're ready for takeoff. And that's it. It's amazing. It feels, the only downside is that the start position, it resets itself back to the both position automatically in game, but the physical device doesn't. So if the moment it gets into start and it jumps back to both, you have to manually change it back to the both position, which isn't really that bothersome. I'm still looking into some ways with the magneto set functions to see if that will mitigate this issue. That it will only go back to the both position when you actually, well, physically move it back into the both position instead of the game doing it for you. Let's see, I think I missed my, yeah, I'm going rather fast, I think. There we go. And we're off. Even if I look at it like the dangling keys on your desk. Okay, it's amazing. I'm trying to recreate this look a little bit off the beaten path. I tried to recreate this look where we have the outer ring and the inner ring with the key in it, etc. And the markings on it. So this will all be in the final version. Right now I'm already glad that I got this working. I found some quirks in the SDK regarding the way the magneto is handled, and that is, yeah, how should I explain it? That there is a magneto 1 and magneto 2, magneto 3 and magneto 4. If you use the magneto function, so the global magneto function, send magneto start or both or left or right, it works fine. The moment I use the send magneto 1 left and right, that's when things get a little bit tricky. The left and right don't always trigger in a proper way. So I'm still finding out why that is. I read into Fora that the set function will fix this. So that will be in the next update that I've been working on, where I will implement all the set functions for the magnetos, the set functions for the nav radios, and many more. So that one is coming. Sorry, I had to get a screenshot of this. Nobody on final? Okay, fine. Oh. I'm way too fast. See, and as I mentioned, my flying skills aren't... You guys have way more experience of flying hours. So I help you with coding, you guys help me with flying. So I think that's a great deal. I'm not quite sure how these parking spots work, but I'm just gonna pretend that I do. Avionics battery is not needed. And then we can just come on, you gotta admit it. I'm just gonna start it one more time, just because we can. Now it's interesting that I put it in both when we load it up after the continue. There we go, it's turned on again. And just as easily we can... Oh. See, it starts at both if we... That's interesting. But we can just easily turn it off. And that's it. So yeah, that was basically all you need to create your own magneto key. We have one rotary switch with 9 positions and 1 pole. We only need 5, so we need to add a physical stop later on. But I think the results we have here already is... let's see, no, I don't have it right. It's already amazing. One thing to note though is that if you started it, so if you've been to start, let's see, I'm gonna show you, it will go back to both. So now if I go back to left, right, and now if I hit off, it's automatically going back to both, and it has something to do how the game handles this. And then I can just go back normally. See, I don't know if it's a bug or what it is in Flight Sim, but the moment you started it and you go to off, it will probably turn it off and then set it to the default position of both for some reason. I especially want to thank all my Patreons that made it possible for these videos to be released, to be made, and to work on the connector. Especially I want to thank Sim Racing for You and Andre. Thanks again, guys. You guys are really amazing. Keep the ball rolling. If you want to support the channel, go check out the page in the description down below as well. And as always, if you just want to support me out with this channel, leave a like down below. Don't forget to subscribe. And I hope to see you in the next one, where we're going to be creating lots and lots of more awesome stuff together.